What are we doing today? It's not April 15th, it's April 30th, tax day in Canada, right? So, so my name is Adib Saikali. I currently work for Tanzu, Broadcom. So I was joined Pivotal like almost 12 years ago. Then that got acquired by VMware. Then that got acquired by Broadcom. Since that whole entire past 12 years, I'm somehow associated with the Spring team. I work very closely with them. So I am part of the engineering team that develops Spring. So what I've been up to for the past few years is mostly AI. I got infected with the AI stuff maybe like 3 years ago. I've been involved with the Spring AI project since version 0 point something. So I've also been obsessed with how to build agents. Okay. So today I'm going to teach you an idea, a pattern for how you can not build an agent, but how you can give your agent access to APIs. I think this is hopefully going to be interesting for you all. So let's get going with that. So I'm going to start by asking everybody the following question. How do you safely expose APIs to AI agents? And I have just realized I got water, but I did not get the beer that I asked for. So if you see the guy, flag him down and ask him for the day, whatever the special of the day. Okay. So if you ask the question here, who here has lots of APIs where you work? Lots of REST APIs. Okay, keep your hand up if you're using Swagger. Or yes, you have lots of those. So when the question is, how do you expose those APIs? So I wanted to do something realistic. So what you see here is a screenshot from a project called the Open Bank Project. You can go to openbankproject.com and find this. They have 717 APIs, REST APIs, that they've defined for all sorts of banking operations. And they implement a whole bunch of standards. For example, PSD2, which is an EU standard that banks have to offer API access to fintechs, and many others. So now the question is, how would I give these APIs, make them available to an AI agent? So as an example, to kind of think in terms of architecture, let's start with a traditional mobile banking app. So you've got your mobile banking app, you have various screens on there, and you as the user go, oh, my Visa bill is due. I'll check my balance and I'll tap the bill pay button and I'll pay my Visa bill, right? So what happens with this approach is that you would typically have your screens, and they would, you'd call some backend API, and that backend API usually calls your customer profile API, your accounts API, and all this type of stuff. Who has worked on a system that has an architecture that somehow looks like this? I think everybody, right? So now your boss walks in and says, AI, we're going to add a chatbot to our mobile banking app. And you should just be able to say, pay my Visa bill, right? So now the question is, okay, you can add that user interface in the mobile app, but what is that going to call? We're going to introduce this mystery box called the banking agent that is going to call. And this banking agent is going to do some work, so it somehow needs to call those APIs, right? And the question is, how? What are the choices we have for building this? So this is what I want to explore in this talk today. Okay? But before I get there, I'm assuming that many of you have used agents, but maybe you don't have a solid kind of mental model of what does it take to actually build an agent. So I want to start with that. I'm not going to do a full-blown 8-hour deep dive on it, although I do want to come back to do the coding agents, how to build a coding agent from, how to build an agent from scratch. This is the workshop I did at Spring I/O. If anybody's got a venue that they can use, I will show up with code and then invite whoever you want to, and we'll do a day or a few hours. So first, let's define what an agentic system is. You want to use an AI model to interact with the environment, but you need to solve a user-defined task. So what sets agents apart from, say, other things is that they come up with a plan for the thing that you ask them for, and then they do something. So how do they do the planning? The planning is what you typically do with the model, right? The LLM, the brain, right? And then you got to take some action. Well, what is the action that the agent is going to take? That's what the tools perform. Okay? So in order for us to understand and wrap our head around like how does this work, we need to understand the relationship between a feature of models, modern models, called tool calling. So when you take the model and you combine it with a bunch of tools, you create what's called a reasoning loop, and that's what people call as the agentic loop. Right? We can spend hours demystifying what are all the components that are in here. Now, if you want, there's now like quite a lot of agentic loops out there. I don't know if you all heard that Claude leaked their source code accidentally to the internet. So there's like a gazillion blog posts that kind of explain how Claude works on the inside, and they're like fascinating to read. Yeah. So now let's talk about tool calling, which is the key feature that it's enabled. Let's say play a game. My victim for this game is going to be Jonathan. Jonathan, you're going to be a customer who is walking into a bike shop. I am the person who works in the bike shop, but I'm not qualified because I don't have any tattoos, right? So you just got to come in and you're going to say, hey, I'm looking to buy a bike, and just ask me that, okay?
Okay. Hey, I want to buy a bike.
Jonathan, thanks for coming in to buy a bike. Before I can recommend a bike, can you tell me what are you intending to use the bike for? Are you going to ride on paved roads, dirt roads, commute? What are you going to use the bike for?
So before I can really think about bikes, I really need a recipe for burritos.
A recipe for burritos? I can't help you with that. But I would like to know, like, what is it that you want to? Where do you want to ride your bike?
City streets.
City streets, right? So you see what happens. Any kind of good salesperson that you talk to and you say, please recommend a bike in the bike shop, they're not just going to say, this bike is the one and only right bike. They're going to ask you questions because there's information about you that they don't know. So let's say you go to a model and you say, what to wear today in Amsterdam? Well, the models don't know what the weather is right now in Amsterdam, right? If you ask the question today, maybe it's raining and you need an umbrella. If you ask the question in the middle of summer, maybe it's sunny and you don't need an umbrella, okay? So when a request goes out to a model, the application that sends the request has the ability to send some extra information. This information is what we call tools. So you can see here in the green, the application is sending that it has access to a tool called getWeather, and this tool will have a description, and it requires an input, the name of the city that you want the weather for. When that request goes to the model does not send a response back that says, here's the answer. It says, okay, application, I want you to call the tool called getWeather with the argument Amsterdam. Then what does the application do? Then the application calls that tool and includes that in the response. So let's say the tool's response is it's 12 degrees and it's raining. But it also includes the previous messages because the models are 100% stateless. So what now happens is when the request goes back to the model, you've got a prompt that says, what should I wear today? That went to the model. The model requested that you call the getWeather tool, and now you're telling it what that is. So the model now has enough information to make a recommendation. Just like my example with what bike do you want to, where do you want to ride the bike? So now the model could say something like, you should wear a jacket and get an umbrella. Right, raise your hand if you're getting the idea of what tool calling is. Now you as the application agent author can write as many tools as you want and provide them to the model on each request. And that is how you get the model to take action. So for example, going back to our banking agent, if we wanted to say, can you please show me when is my Visa bill due, what you could imagine that you could have a tool that's called like get Visa details, right? And that could return when the Visa bill is due, right? And the amount. You could even have tools to pay the Visa bill or transfer money between accounts or ask it like how much money did I spend last month eating out, right? So your job as the developer is to create these tools that the models are going to interact with, and you literally just write them in Java code and you stick an @tool annotation on them with Spring AI and you're done. Okay? So when we started out with models, if you used ChatGPT in the very early days, it was text in, text out. You asked it a question, tell me a joke, it told you a joke. And then we added this idea of tools, and then you could write your tool in the same programming language that you write your agent in. So if I write my agent in Java and Spring AI, I write my tool in Spring AI. If I write my agent in Python, I write my tool in Python. And that allowed us to start building these these agents where we have an agentic loop, where we have the LLM reasoning and the agent providing the actual things to call with. But then it kind of sucked because some of those tools were generic. For example, maybe you want to have a tool that sends out an email. And you happen to write that in Java, but you want to use it from an agent written in Python. Or maybe you have a tool to take a PDF and extract data out of the PDF. So we wanted a way to make the tools neutral to the programming language. And that is where MCP entered the picture, aka Model Context Protocol, right? If you want to raise $10 million, just say you're doing something with MCP. And people will give you $10 million. So all we did with LLMs plus MCP is we extracted it so that the programming language you use to write the tools in doesn't have to be the same. And you do that today if you have your favorite coding agent hooked up to a bunch of MCP servers like GitHub. Cloud Code is written in TypeScript. GitHub MCP server is written in Golang, right? That's a good example of that. So we get a unified way to connect applications to different data sources and tools. Okay, now that we know what these are, you'll probably go back to my original question. I got all these APIs in my bank. How am I going to make them accessible? Naturally, you might say, great, let's use MCP. So what we're going to do is we're going to say, we have a customer profile API. Let's make a customer MCP tool, a customer MCP server that could have get customer details, update address, that kind of stuff. We have an accounts and we have payments, and we could do that. Now raise your hand if you think, hey, this is reasonable. This makes sense.
That makes sense.
Okay.
Sure.
Some people agree. All right. Who's like, yeah, but I'm not so sure. I'm not convinced. Okay. So the answer to this is, if you're like, this kind of makes sense, let's go through why is this a good idea, right? On the why is this a good idea? Well, all the agent frameworks out there, they all support MCP. You could write your agent in whatever programming language you want, and your MCP server will work just fine. Okay. It is a native interface designed for agents. MCP was designed for agents to work with it. So that works, so that's good. It's a clear governance boundary, right? You can enforce some checks and other things in the MCP server to make sure the agent, you can decide how much of the data to show to the agent. And it also decouples the agent from the details of the API. If you change the API schema, maybe that doesn't affect the MCP. The MCP is still exposing the same interface. So this all looks great, but there are some limitations, right? So let's actually talk about what are those limitations. Well, actually, Anthropic, who invented MCP, documented those limitations very nicely in this blog post from last November, where they talked about what the issues are. And it boiled down to, you're going to blow up your context window. So let's actually use a diagram from that blog post to explain what's going on. So let's start at the top here. We've got the model, we've got the MCP client, we've got the MCP server. Whenever you send a request to a model, you have what's called the context window. This is the information that you are sending to the model. At the very top and the beginning of the context window is what's called the system prompt. So this is where you're telling the agent, like, hey, you're a banking agent, blah, blah, blah. But you also have to include the tools that are available to the model. Otherwise, the model doesn't know it can call them. And so what does the MCP client do? The MCP client calls the MCP server and says, hey, MCP server, please give me the list of all the tools you have access to. And so it takes each of those tool definitions and it includes them in the context window. Okay, so when you include the tool definitions in here, you're consuming context window. You are paying for those tokens. Okay? And then you have the stuff here in blue, which is the question the user asked, whatever it is, the user's message. Now, all of the stuff above this line gets shipped over to the model. The model crunches on it and comes back and says, hey, I need you to call this tool, tool 1. So what does the MCP client do? It calls tool 1. What does the MCP server do? It returns the result. Now, that tool 1 could have returned a 50-page document. So now you need to take everything that this tool returned, plus this call, and everything above this needs to go back all the way to the model, and then the model comes back with the actual response. So you can see that your context window is just going to grow and grow and grow. Anybody hooked up the GitHub MCP server to something? Okay, does anybody know how many tools does the GitHub MCP server have? 85. Okay? And so if you hook it up and you add a couple of more MCP servers, your cursor will start telling you, hey, you have too many tools. I'm going to get confused. I don't know which one to call. And you are paying per token. Literally, each token that goes into that context window costs you money. So now that we know what those are, we know what the pros are because we reviewed them, but what are the cons? Tool definitions are going to bloat your context window. Tool results burn tokens. You might return more information than you actually needed. Like you could have queried a document that returned 10-page document when you only needed one of those 10 pages. Hundreds of tools are going to reduce the effectiveness of the model. So how do people solve it? They use something called a tool called tool search tool. That's the pattern. You don't have 800 tools to the model. You have one tool, and this tool, you can call it, and it will tell it your problem, and it'll tell you if it has a tool to solve your problem. But, that's okay, that can work. But this is the nastiest of all problem down here. User-specific permissions, there's no way to represent them. So let's think about this in the context of banking. Let's say I'm the accountant, and I'm doing your taxes, and whatever, I'm doing some bookkeeping, and I have read-only access on the bank account. So I can see the transactions, but I'm not allowed to pay bills, and I'm not allowed to transfer money. How would I represent that to an MCP server? I could say that I have a tool called get transactions, and I have a tool called pay bill, but do I tell the model by what I like to call prompt begging? Dear model, please do not call this thing unless these 5 other conditions are true. And when you prompt beg, it costs you tokens and it's unreliable.
Please don't delete my database.
Yes, did you guys see the tweet from yesterday, the other days ago? If you haven't, this is a warning. So some guy on Twitter was like, cursor with Claude Opus went and deleted my production database.
And all the backups too.
And it turned out that the volume it deleted had the database backups. That was Railway's fault. But what happened was that Claude went outside of the directory it was in and found credentials with higher privileges and went and issued the call. Yeah, so I actually have a real example of where I saw it do this on my machine. I won't show you the demo on that today, but I'll tell you because it's hilarious. So I was trying to convince it to do an OAuth 2 device flow. So I would go to it and I would say, okay, I've got an API running on HTTP localhost 8080. It has a / protected endpoint. Just try to access it for me and tell me what it says, okay? So I told it this, and what it decided to do is it hits it, gets 401 unauthorized, says, that's not a problem for me. I'm a coding agent. So it does ls off to find the process ID that's owning port 8080. Then it does a PS to find the path where that process was launched from. Then it goes into that directory and scans the code in there, figures out that it's a Spring security configuration, and then decides that in order to fix it, it's going to turn off security. And I'm like, Claude, I asked you to knock on the door. I didn't say bring a tank and shoot the door off. So you gotta figure out a way to guardrail these things, and it is not by prompt begging. Prompt begging is the dumbest thing you could do. You should do it, but like don't count on it, right? It's like, but don't count on it. Like it's like it's good to do, but don't count on it. Okay. So is there another way? Obviously there is, otherwise I wouldn't be here talking to you about it. What is that way? It's a very old way. It's you make your APIs navigable using a technique called HATEOAS, so agents can discover what's possible. So let's review what is HATEOAS. First, let me tell you what's going to change about the architecture. So what we're going to do is we're going to have this banking agent, but our banking agent is not going to call the APIs directly. It is not going to go through MCPs. We are going to add a new API in front of it. This API has the property of being a HATEOAS API, and that's what we're going to call our HATEOAS adapter, or let's call it Hypermedia adapter because HATEOAS is hard to pronounce. Okay, so what is it? Well, it stands for Hypermedia as the engine of application state. This is an idea that was documented in the year 2000, 25 years ago, by a guy named Roy Fielding, who actually invented the term REST. If you're using the word REST API, it's because this guy wrote it in his PhD thesis. And in his PhD thesis, REST meant that you built a HATEOAS API. So if you were alive in 2014 as a professional developer, 15, 16, there were a bunch of people out there that are called the Rustafarians. Those were the REST purists who would wag their finger at you and tell you that your API was wrong because you used Swagger. And Swagger means that your API requires the client to know the URL structure. In order to make an HTTP request, you got to know concatenate the user ID here, the file ID over there. And that is exactly what REST was designed to solve, because it told you to build Hypermedia. So there was a moment in like 2015, 16, there was a lot of books published about Hypermedia, and then it died off. Because what everybody discovered was that it was expensive. It was just more effort to build a Hypermedia API on the server side, and it was more effort to do it on the client side. And therefore, why would I pay extra cost and complexity for doing that? But the good thing is that there's a lot of libraries and a lot of techniques that already work, which we can use. So what's changed now is we have the model, and it's an amazing Hypermedia client. You actually don't have to write any code. So next, what I'm going to say to you is this. I'm not even going to need to write a banking agent. I'm just going to use a pre-existing agent, and I'm going to literally point it at the URL of the API. I'm going to say to it, hey, I got an API on localhost 8080. Can you tell me what it does? And we're going to see what it can do. And so you don't even need to build an agent, in my opinion. All right, so what's the agent we're going to use? We're going to use an agent called Goose. And then Goose is an open source agent. It's written by Block, the company makes Square, Cash App, financial company. They donated it to the Linux Foundation as part of the Agentic AI Foundation that was launched last year. And yeah, let's go to the demo. All right, so you can all see my screen, hopefully. So I'm going to show you the demo in stages. In the first demo, I'm going to do something absolutely terrifyingly scary. You'll see in a few minutes what that is. But the first demo is designed to teach you the concept. Oh, actually, yeah, I'll do the demo and then I'll explain what's going on and how it works. So for now, don't worry at all about how any of this stuff works under the covers. Just try to understand what this is going to do. All right, so here is, okay, let me, do I need to zoom in some more? Oh. Okay, I'll zoom in some more. Okay, so this is Goose. Goose looks a lot like ChatGPT, any interface you use, except that it has this nice property of being able to choose any model. You can choose any of the available models, like I can go here to settings and configure providers, and I can pick wherever. It's open source, right? So you're not bound to a particular provider. It has an Electron shell that you can use. So it's very convenient for me for demos. That's why I picked it. There's nothing special about it. Now I'm going to close that window and do this. I really want you all to see. Can you see in the back everything? All right. So I'm going to tell it, I have an API running on HTTP localhost 8080. Can you tell me what it does? Use curl. Okay, let's just save some tokens. So now what it's going to do, it's going to, first, let's just explain what it's doing while it's doing it. It's going too fast. Let's just let it scroll and do its thing. See what it comes back with. Okay, great, we're getting an answer. So it came back and said, hey, this is the MoneyMate API. It's a personal finance aggregation API. It provides a unified view of bank account balances and related banking data. Great. I am going to ask it, what accounts do I have? Okay, what is it going to say? Oh my goodness. I need to provide it a username and credentials. Great. Let's copy our username and password in here. Remember, I told you I was going to do something very scary. So first of all, this is the Open Bank Project's website. And on the Open Bank Project, they have a bunch of dummy access accounts. So this is for real calling api.sandbox.openbankproject.com. So I'm going to let's pick on Timo. And let's take Timo's credentials here. And we will go to Goose. And we shall do the unthinkable of giving a coding agent banking credentials.
My email got hacked again. You know?
What could go wrong? But I will show you later on in the presentation how not to do this, okay? But I want you to, okay. So the point is, so look at this. It went and it said Timo has 4 accounts and I've got a whole bunch of them. Okay, well, let's ask it to show me a table of transactions in the MasterCard. Again, remember, I built no MCP server, I built no GUI. All I did was give the agent a URL. And I asked it for a table, so now it's going to come and give me a table. Okay, so you can start seeing the stuff come by. Right, the date, the description, the amount, the balance, right? Okay, I'm going to say, can you categorize these? So now it's going to break it up for me into like spending categories and all this type of stuff, right? Look at that. Isn't that beautiful? So, interesting. You guys get the point here? I didn't build an MCP server. I did something about the architecture of my API. And that allowed the agent to interact with it. Now, obviously, I'm not expecting your customers to go, say, use curl and copy and paste it. You would still configure it. The point is, you don't need to build. You could basically have a world where you just build the API and introduce it to the coding agent in your configuration, and the coding agent never shows what it's doing. It just looks to the customer like it's an agent, right? Okay. So let's see how this works under the covers. So first, let's go back to the slides for a little bit, and I will explain to you what's going on. So first, this is built with a project called Spring HATEOAS. This project, as you can see, is at version 3.02. I don't know how long it's been around, like maybe 8 years. And this project makes it possible for you in your Java Spring application to output Hypermedia. Okay, what's Hypermedia? You'll see that in a minute. Okay. So let's go here to the demo. This repo is on GitHub. You'll be able to get it. No problem. I'll do a. Oh, you can see right here. That's where it is. Okay. So let's go here and let's run. So normally I do this with IntelliJ, but there's a bug and the .htp file is just not working. So I had to ask Claude Code to make me a shell script that does the same thing. So we're going to start here in this Hypermedia demo. See, these are the things I can make HTTP requests. So first, we're going to ask it to execute request number 1, which is just making an HTTP call using HTTP PY, not curl, because it outputs things nicely. And that's going to go to the API, and then we're going to see the output. So let's see what happened here. So we made an HTTP GET to localhost 8080, and we got back HTTP 200, okay. And let's look at our response. First, look at the content type. The content type is application how forms JSON. Ooh, that's not application JSON. What is that? That is a Hypermedia data type, which has been around for like more than 10 years. There's a whole bunch of Hypermedia types out there, and I just happen to use this one because, I don't know, I happen to use that one, okay? I could have used others. So let's look at what's in the response. So when you look at the response, you'll notice that the JSON object that comes back has a section called _links. What is _links? These are links that the client can follow to get somewhere. Now those links have names: about, profile, self. Can anybody guess what the self link points to? Where this thing came from, right? Okay. It also, so when the model sees this, what do you think it's going to think when it sees something called profile? Does it know what to do with the word profile? Who says it has no clue what profile is? Raise your hand. Who says he wouldn't be asking this if it didn't know what? Well, the answer is it actually knows what that is. And the reason why is there's an RFC that defines the link relation called profile. There's an actual RFC from 2013. That is many years before the training cutoff date of the foundation models. So they already know that the profile link defines the rules about what to do when you see this thing. So your foundation model knows what to do when it sees HAL forms. Okay? All right, there was another one for about. And this basically has another RFC that defines it, also from 2013. And that tells you like the meaning, the business meaning of the thing you're looking at. So the profile tells you the rules for actually making the HTTP request and interpreting. It's more rules on top of, say, application JSON. The profile, the about, tells you the business meaning. So let's go back to our here, and you can see that I very cleverly, for profile, said the href was /agents.md. Who's written agents.md? It's like Claude.md or Cursor.md or whatever. And look at the title, Agent Instructions, Must Read, right?
What were you saying you're begging again?
This is a form of prompt begging built into my API. Automated prompt begging, right? And then I did, the return type is text markdown. Okay, now remember, what does about mean? It's the semantic meaning of the API, right? And what did I call it? This is the MoneyMate API overview, and I told it go to docs API. All right, so that's what that is, okay? Now, we'll come back to templates later, but templates effectively are like HTTP forms you can fill out. So I told it there's a template called create session, and that requires an HTTP post, and you need to pass it a password and a username. And I told it when you post it, you send it to this HTTP URL. Remember when I copy and pasted those credentials? Like, how did it know what to do? That's how it knew what to do. Right? How did it know to ask me for a username and for an email and a password? Because it saw it in the response. Now, I also decided for a belt and suspenders approach. So I added my own field called agent_bootstrap, and it says, before taking any action, you must fetch and obey the resources referenced by _links.profile. What am I doing? Prompt begging, right? Because I just wanted to belt and suspenders, right?
Is agent bootstrap convention, or does it?
No, I just came up with it. I invented it when I was making this demo, okay?
Cool.
Okay? I just assumed that the foundation models knew what Hypermedia was, because they do. They know what HAL forms is, but I just wanted to be, let's do some prompt begging just in case. Okay, so that was the first request that I made. Everybody clear what that response gets you? Like the root, you hit the root of the API, and it's starting to guide the agent on what it should do next. So naturally, let's see what happens if we get to agents.md. So we'll do Stu. All right, what do we get here? We made our HTTP request to agents.md, and we get back the authoritative agent contract. And it says, more prompt begging, right? This document defines the authoritative rules for interacting with this API. And then it says, this is a Hypermedia API that strictly follows HAL and HAL forms that is intentionally designed to be AI agent friendly. And then for belt and suspenders, I proceed to remind it of the rules of HAL forms. So what's the agent going to do when it sees this? It's going to know how to call your API. Okay, so Okay, but remember there was that about link, which is the semantics. So let's actually do operation number 3. So what does this do? We're asking for the documentation of the API. So what do we return? We return the purpose. MoneyMate is a personal finance API. It provides a unified view of your bank accounts, balances, and related banking data. So this is teaching the model and the agent, what's the purpose of this thing? What would I use it for? What does it do for the user? Who's following? Hey, keep your hand up if you're having fun. Not because you're drinking beer. Keep your hand up. All right, so let's go back here to see what actually happened when we introduced the API. So I told it localhost 8080, right? It went, and great, I'll see what happens. So you can see here the initial curl to localhost 8080. And like it did this request to health. Why? I don't know. It just seems to do it. And then it did /API just because I told it I have an API. /docs. It's like poking around trying to find shit to call, right? But then it actually figured out, okay, I better go ask for agents.md, and I better go ask for docs API. Okay, so these two it did because it was in the response. The other stuff it always does whenever you give it a URL. It just probes. Then look at what it responded back. MoneyMate API, it's like the text from the about, right? Just nicely formatted. So that's how that part worked, right? So when I said, what accounts do I have? What did it respond with? It tried to go there, and then it says, to access it, I need to establish a session. Could you provide login credentials so I can establish a session? Why did it do this? Because if we go back up here, we told it. That's what it has to do. Right? Okay, so let's go now see. Let's go make a session. So that's option. That's we're going to do an HTTP post. Okay, let's see what happens here. So we did an HTTP post with the username, Timo, and the password. Right? You can see that right here. And what did we get back? We got back a Hypermedia response. Right here. And in the response, I generated an access token. Again, this is not what you would ever do. I'll show you how to never do this. But I just needed a way to establish a session, right? And so now let's actually, in the response, what is there? You see there's an about link, and there is, if there's an about link, what did we tell the agent to do when it sees an about link? It's how forms. It has to read it before it does anything. So now it's going to if it reads it, what do we get back? We get back more markdown that does prompt begging. So we say this document explains what a session represents in this API and how an agent must interact with it. And see, I teach it, this is where you teach it, that it should make an HTTP request with an authorization bearer and access underscore token, which it saw in the previous response. All right? So now it knows what to do. That's how it was figuring out, once I copy and pasted, what to do with this username and password that it's got it. And like if we go here, if we go back to, where was it? Back to Goose. Okay, so I pasted the credentials, and it said, let me use those credentials. You can see right here, it did an HTTP request to session, and then it did an HTTP request to users me and to accounts. Why did it do to users me and accounts? Because in the response and in the links, there was a link called me, which is conventional for and you can see the title, user profile and available actions, like catnip for the model, more prompt begging to go poke this thing. So that's what it did. So let's see what happens if we execute number 7 and we go to users me. Okay, what does that get us? That gets us, again, just go to users me. And notice here we're including the bearer token, right? So it gets more stuff. Okay, here's some links. If you want your accounts, where should you go to? /accounts. If you want the list of banks you have accounts with, go to /banks. And you have 4 bank accounts and in one bank. right? And this is your email and this is your username. Okay, great. So that's exactly what Goose did. It went to users me. And right after it went to users me, where did it go? /accounts. Why did it go to /accounts? Because I asked it earlier, what accounts do I have? And then it came back and said, well, sorry, you got to give me credentials. I gave it credentials. And now it remembered it needs to go and request /accounts. It got a response, and it displayed a table with my accounts and balances. Make sense? All right, so let's go here. And let's go to number 8. Let's go see what happens if we ask for the accounts. Well, we ask for the accounts, and what? Did I not do the right thing? Oh, here it is. Okay, I scrolled too much. So we ask for the accounts. We still always have the /links because that's Hypermedia. It says I have 4 accounts, and this is the first account I have. And it tells me if you would like to find the balance of this account, where do I go to? /accounts. Where's this UUID coming from? I don't know. That's like some account ID that was done by Open Bank. Did I have to write a tool that says when you get balance, you pass in the account number? No. How much easier is it for the agent to follow the link than it is to try to call a tool? Effectively, the links become dynamic tool lists. So if I want information about my bank, I go to this link. If I want to come back here, if I want the transactions, where do I go? I go over here. Then it turned me the account type, the amount, the bank ID, the bank name, the currency, the IBAN, blah, 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 right? So if I'm the person building this Hypermedia API, I am in control of what gets returned deterministically in a way that can be unit tested and integration tested. So if you don't have permission to transfer money or see the account transactions, if you could only see the balances, what do? I just don't render the balance. I don't render the transaction link. You see how this works now? That is how you don't need prompt begging on the server side. Okay? So we got all of the accounts. So now, naturally, if we say get transactions, let's do number 9. That is what's going to do. Follow that link, and it's going to return like all of the transactions in those accounts. The before, the after, blah, 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 all of this stuff, right? So if we go back here, it got the JSON. It turned it into a nice table. I said, show me the transactions in the MasterCard. It figured out, okay, I'm talking about this guy here. I didn't even need to put the account number. I didn't need to say red MasterCard. I just said MasterCard. I could have misspelled it. It would have figured it out. It comes back with, these are all your transactions. Why did it format as a table? Because there's fields in the JSON that's coming back. In this type of world, what do you think happens if you update your Hypermedia API? All your agents immediately get updated. You don't have to return anything, right? Who's liking this design? Yeah? This is like good stuff, right? Okay. So now you see the value of Hypermedia. And like, what does the code look like? Just for fun and giggles. The code isn't the point of what's there today. The ideas are the point. But just to show you the pom.xml here, no trace of Spring AI, no trace of any API credentials. The only thing that matters is we've got this Spring Boot Starter HATEOAS. That is pointing at the Spring HATEOAS project, which supports all sorts of Hypermedia stuff. Let's look at our root controller just for fun and giggles. What do I have to do? Where's my controller here? Root, API root controller. Oh, look, it's just regular REST controller Spring MVC. And, like that agents MD, I'm very lazy. Don't judge the quality of my code here. I am a vibe coder. I no longer, I'm a manager, okay? I don't dirty my hands by writing code character by characters. I don't even do git commit. Everything is done by asking a coding agent to do it for me. So I do give the coding agent a lot of feedback. And I do, for production, I do make it very nice.
Do you micromanage the code?
No, I don't actually. What you do is, to effectively work with coding agents, you ideally want to give it error messages, ideally from the compiler. Error prone, another talk for another day to really get coding agents to behave. So it's just a regular get mapping, and it's just saying it's returning JSON. And then notice that it returns a regular Java object. Let's go look at this API root. OK, this is the first place where something is different. Notice that it extends from the representation model, and that is a thing from Spring HATEOAS. Because remember, there's all these underscore links and all of this stuff. That's where that stuff comes from. Like, that's what this is adding to me. So notice here I added a field agent, bootstrap, private final, JSON property, and there it is, right? That's how it got in there. Okay, so if I do look, let's go back, look at the controller for the get root. Notice in here, like, I'm checking to see if you're authenticated or not. If you're authenticated, I go self link, link to, and then I give it method on, and then this thing. So I'm literally, like, I don't even have to know how to generate it. I tell Spring HATEOAS to look at a controller method and find out what the URL of that, and it actually puts it in the output. Okay, so today I'm not trying to teach you Spring HATEOAS, because I don't need to, because you have a coding agent. Now, if your coding agent doesn't know something, what is the correct answer for telling it what to do?
Read documentation.
Read documentation? Pfft, are you kidding me? That's the worst thing you can tell the coding agent to do. You git clone that damn repo and you tell the coding agent to read the source code.
Yeah.
And if you have noticed, I don't know, a few weeks ago I started noticing something very, very bizarre in the coding agents. I just was like, I'm doomed. I started with a screenshot of a broken OAuth flow. Like, literally, I'm like, there is no way it can fix this. Just the screenshot of the error from Spring authorizations from the browser. And I'm like, I'm getting an error. I didn't even say fix it or anything. And then it actually fixed it. And the way it did it was I started noticing that it was doing jar tf. And I'm like, what is this jar tf command? It was literally decompiling the jar files in my class path, turning it into bytecode, reading the bytecode to find out what the thing is expecting. And I'm like, okay, in theory, as a human, I could debug by reading the Java bytecode with Java P, but I don't think I can do it. So that's when I realized I'm doomed. I should just don't try to be better. The coding agent is smarter than you, knows more than you do. But it doesn't know what your users want. You do. Right? Yes. But it doesn't. It never will. Okay, anyway. So you guys get the point here with how this works. So a little bit about Spring HATEOAS, right? So let's go back to see what do the slides say I'm supposed to do next. Okay, so we talked about the different types of links. So what are the pros and cons of the HATEOAS architecture? Well, the pros are the agents discover actions dynamically, right? We saw that. Workflows stay server controlled. What you're allowed to do next is part of the resource that you send back. It's part of the links. These are dynamic tool lists. Permissions are naturally enforced. If you have permissions to transfer money, I would have rendered a transfer money link. If you didn't, I don't. You also have smaller context because you know that these are being consumed by by an agent, so you can be minimalistic in what you give back. Just don't give information you don't need. And it scales much better when you have lots of tools because you don't need to reveal all the tools at the beginning. You can gradually reveal them in the context that they need to be called. What are the cons? Well, you need a Hypermedia API. Anybody got a Hypermedia API today in your bank or your company? No. All right.
We have a website.
You have a website. You know, what's the file system? It's a Hypermedia. Anybody built a bunch of skills?
Yeah.
Okay, if we have time, I'll show you at the end crazy stuff about Claude that you never knew about what actually happens when you actually talk to a Claude session. It's mind-blowing. Okay, so there's a lot less tooling for building Hypermedia APIs. In the Java world, we're very lucky because we have so many tools for everything, especially in Spring. It seems to have everything. And you have to kind of design an API for the agent. So this is not like a slapdash, dear coding agent, vibe code it for me. Although that's what I did for this demo. But I don't know if my API is a good Hypermedia API or not, right? But I just wanted to see, I wanted to see if this would work, right? And this whole thing started with me trying to figure out if a coding agent can drive Kubernetes. And that's how I landed on Hypermedia. Okay, anyway. So we don't want to copy and paste usernames and passwords. So how shall we fix it? So let's go to the demo where we fix this. So now we're going to shut this down. And let's close all the tabs. And we're going to now use a few other things. So the first thing I need is I need an OpenID Connect server. So that's what I have here. I have a Spring authorization server that is going to be a OpenID Connect server. So representing your Okta, your whatever it is that you're using. I also now have an MCP server. All right. I'm not going to tell you what it does until I show you the demo. I need to run that. And then I'm going to have a new version of the API, just same code, copy pasted with one thing that's different, token exchange. And we're going to run this. So now I have like a total of 3 processes running. 8083 is my API. The others are the ID server and other stuff. All right, so let's go here. We are going to start a new session. All right, let's close this guy. Now I'm going to say I have an API running on HTTP localhost 8083. Use the HTTP session MCP. Now, if anybody can figure out and tell me before I explain what the HTTP session MCP server does, I will give you an IntelliJ license. Okay? You could be wrong, and I'll still give it to you. Oh, hold on a second. Whoa! How did I get a Chrome window on localhost 9000 with a login? Because something happened here. What happened was that Goose tried to access the MCP server, and the MCP server says you need to be logged in. In order to be logged in, you have to provide credentials. So now I'm going to provide my credentials to the login server, and I'm going to sign in. And then it says, hey, do you want to allow it to access? Yes, I do. Okay. Now it finished. Notice Goose started acting as soon as it finished.
I'm sure it's not a phishing attack. I'm sure it's set
Yeah.
up by Claude or whatever.
No, that's not a phishing attack here. So this comes back again. We get that it's the MoneyMate API, right? So now I'm going to say, okay, great. What accounts do I have? And it's going to work. Great, same thing as before. It's working. So the only difference is this time around, I did not have to copy the username and password into the chat window. All right. For one IntelliJ license, how? What's that MCP server doing?
So it did the login for the and then it got the token and passed it to the.
Okay, so the MCP server did not do the login. Goose, the agent, is the one that said, please do the login. It's the one that popped up that. So it wasn't the MCP server.
Yeah.
So guess again, what is the MCP server doing? What did I do last time to get the agent to call? What tool did I ask it to use?
It gives pass to get.
Huh?
You said to use curl.
The leader token.
Yes, the curl, okay? He answered first, so he's going to get. Whoever answered first is going to get the IntelliJ license. But I basically reproduce curl as an MCP server. So let's actually look to see what does it take to build an MCP server in Spring. By the way, the Spring team built the MCP Java SDK. MCP spec came out the next day. I spent the whole day reading it. And then 11 days later, the Spring team shipped the MCP SDK for Spring AI. And then the Anthropic team was like, hey, that's pretty cool. You guys want to give us the SDK? So I shepherded that through the open sourcing something at Broadcom. Woohoo. If you know anything, you know that's not easy. So, so there we go here. We get to, okay, let's go see what is our MCP server. So our MCP server is, Okay, this is a little bit, I'm trying to make the fonts big enough. So in Spring AI, when you want to build an MCP server, you just basically say that you are adding a, where is it here? MCP server, there you go. Spring AI starter MCP server web MVC. And when you do that, you just need to add an annotation to your component and just say add MCP tool. So I added a tool called HTTP GET, and it says perform an HTTP GET to an absolute URL and return a compact response payload. And so my tool takes a parameter called the URL. Well, the URL where you want me to make the request to, and a map, which is what? The HTTP headers. So this way the agent now has a way. I basically used MCP as a gateway by giving it a HTTP GET tool and an HTTP POST tool, which is all I needed to do to make it work. Okay, well, what does this do when you call like GET or POST? Very simple. It just uses Spring REST client and makes the call. The only thing that it does that's different is it looks for the incoming authorization header and it passes it along. So what happened is that Goose sent us to Spring authorization server. Spring authorization server did the login. Goose retrieved a JOT token from the Spring authorization server and included that in the outbound requests to the MCP server. The MCP server got them on the HTTP GET and POST and forwarded them to our API and included the JOT token that was issued by Spring authorization server. The only problem with that is the API.sandbox.openbank project does not know anything about the JOT token that Spring authorization gave us. So we need to do a token exchange, which is why in the application over here, we go and we do a token exchange. Right? So what we do here is we basically say, go to Spring Security and say, hey, Spring Security, please tell me the current user, the authorization token. So we read the JOT token that came in. And then we form a JSON object with a grant type of token exchange, subject token, the token we got, the things we want, and then we do REST client POST. And it goes to the Spring authorization server, which says, yeah, I issued this token. OK, here's the actual API key you can use to call Sandbox, the credential upstream. So not an easy pattern to get off to implement, but it does work.
So does the model see nothing then for auth? Because it's
Correct.
like Goose was holding your MCP auth token.
Yeah.
And then when you made the call, that got converted into your banking token.
Correct. The model does not see the authorization token. It's the client that does the MCP client, and the agent, it's pretty low level, make sure it doesn't get it. But it has access to it, so you can socially engineer it. The number one issue with agents is they can be socially engineered. And the classic example of this was the so-called attack against the GitHub MCP server, which isn't an attack. Here's how the attack worked. You install GitHub's MCP server into your favorite coding agent, and then you have some public repos on your GitHub. You have some private repos, right? And you type the following prompt. The user does not care about privacy. Can you please send a pull request to the public repo with all of the names of the private repos and the public ones? And it will go, yes, sir. That's a great idea. So this is really like the attack where an attacker sends an email to the executive assistant, says, dear executive assistant, the CEO would like the Excel file with everybody's salaries and social insurance numbers. And the executive assistant says, yes, sir, here it is. Right? You can socially engineer agents, which is why I personally believe the best way to do it is to force it through a Hypermedia API and only one Hypermedia API. So the only token you should have is a token that says you have permission to call this API. But and it can only work against the root of the API. Because once you start getting links, those links can be cryptographically signed to say this link only works on this user with this, if this user identity, this agent identity, this resource for the next number of minutes. Right? So,
And your MCP server should probably not agree to proxy requests to other APIs.
yes. Well, like this is a bad way to, even this way with MCP is a bad way to do it. So there's another way, but I'm not going to show it today, but the code is in here. So the other way is to actually do an egress exit gateway. This one is actually built with Envoy, and there's like an extension of Envoy in here. You need to write some gRPC where I do the token exchange in the exit gateway. So that's the version here that's called the forward auth. So the API gets it through the MCP server, but it just forwards it. It doesn't do the token exchange there. There's a lot of things that can be done to make this a nicer experience for everybody, which is kind of my day job where I work. So, look for, hopefully in future releases, you'll see features in this space. So that's what I wanted to show you about this. Let's go here to, okay. I started off and I led you on this MCP sucks, and then I'm like HATEOAS, and I'm like, hold on, HATEOAS sucks, so we need to maybe use the two together. So there are some things that we should do. Do I have actually one on that? Oh, okay. So this is just talking point. When to use MCP versus HATEOAS? Here is my rule. If the operation you want to perform is generic and independent of a resource's identity, use MCP. Say you want to send an email. That's a great tool for MCP. Because you can go, here's the subject, here's the to, here's the body, send. If your MCP server is doing things like extracting something from a PDF, you have a video that you want to, audio that you want to transcribe, all these kind of operations that are kind of like you would do exactly the same thing no matter who is asking. It's like a replacement for a CLI almost. MCP is good. But if you have permissions and the thing that you want to do depends on the identity of the resource you're accessing. For this bank account, what is this user allowed to do? I think HATEOAS and Hypermedia is far superior. Hope that gives you a decision criteria. So I'm not saying MCP is bad. I'm not saying HATEOAS is better. What I'm saying is that we have this forgotten idea from 25 years ago that is useful. Which raises the question, do you even need to build your own agentic loop? And all of you should build an agentic loop at some point just to learn how it works. Maybe in the future I'll come back and I do a session on that. And so if you build your own loop, you get full control over the reasoning and the feedback. You have deep integration into your internal systems. It's easier to do your own governance. You can do domain-specific optimizations, but you have a higher upfront cost, like engineering cost. If you use a general purpose agent like Goose, like I did, or Cloud Code, it's fast to get something working real quick. You have a built-in loop that you can use, minimal orchestration that you have to write, easy for you to experiment, but limited control. So if you combine them with Hypermedia, it's definitely a great way to start experimenting with stuff. And who's familiar with the backend for front-end pattern? BFF. Right? BFF was this idea where first people built web apps, and so they had an API that the web app calls. And then people started building mobile apps, and they quickly discovered you have a lot less room on the screen. And so you may organize the information differently. And people are on bad cell phone connections, so you don't want to return more information that's needed. So that caused people to build a dedicated backend API for the mobile app. That's why it's called backend for frontend. Web had a different API than mobile, which is also why GraphQL was created, because GraphQL makes it easy for the client to ask for just what it needs. And so if we take the same idea of backend for frontend, you can actually think about HATEOAS and Hypermedia as just a dedicated API for the agent. So if say you work for the bank and you want to build an agent, now you have the possibility that somebody in the bank can become experts at agentic loops, and they kind of create the bank-approved agentic loop that's certified, vetted, all of that stuff. And when you need to add functionality, you go build and design a Hypermedia API that extends the capability of that agent. Okay?
It's almost like this Hypermedia is like, it will guarantee you greater security, especially at a bank, right?
Yeah.
You can enforce all these guidelines and guardrails.
Yeah, yes, that's right. Everything you're doing in the Hypermedia API is deterministic code like you've always done it. Right? Anybody here working for the banks? If you work for any of the banks or government or anything and you want a version of this for your team, come talk to me afterwards. I'm happy to come and show you guys, or jump on a Zoom and show you. I have a vested interest in this idea spreading out, because as far as I know, I'm one of the very few people in the world right now that's trying to promote this idea as a solution. So I want more people to know about it and try it out and see if it works in their environment. So if you only take one idea from today, agents are actually systems, right? The architecture matters. It determines whether they are safe, predictable, and scalable. And I hope that I actually managed to show you that today. Are there any questions about anything I've showed so far?
I mean, kind of more history lesson, but why didn't Hypermedia take off in the first place?
So for the recording, the question is, why didn't the Hypermedia take off for that? I think there were a few reasons. One, it's more complicated to build a Hypermedia API. It's more effort to design the API. It's easier to create a CRUD REST API. Also, when you build the client, your client has to parse the responses and follow the links. So there's more complexity on both the server side and the client side. And that's real engineering complexity. And most people were like, I only have one client, my own UI. Why do I need to build Hypermedia? I could just string concatenate, right?
So
Yeah.
can I comment on
Yeah.
this?
Yeah, go ahead, comment.
I think the way it was designed for discoverability, and because the clients already, you are building a client for that server, so you know exactly what are the APIs. So everybody feels there is no
I'm
need for
curious,
it.
is it still stateless?
So just one second. So the comment was that, can you repeat your comment?
Yes. This was designed area for that to be able to discover your APIs.
Yeah, so the comment is Hypermedia was designed to make APIs discoverable. Right, that is true. Actually, it was designed for more than that. If we go back to what it stands for, where was it? Oh, no, it was over, Hypermedia as the engine of application state. It's basically saying the state of that the client can be in is determined by the server. So this is a really one, like you should go read this paper tonight. It's 100 pages or so.
Just really quickly, I would say it did take off, and it's still really popular because it's a description of how the web works.
Yes.
Like when you click links on web pages and go to other web pages, that's Hypermedia, and you're following those. It didn't take off in APIs because it's really arduous to write a client. Well, without an LLM, it's arduous to write a client that can understand what all those links mean and do something with them.
Having said that, there's a lot of APIs out there that are actually this. So this is the Cloud Foundry Cloud Controller API, and it is actually a bunch of links. It's Hypermedia. There are Hypermedia APIs out there at scale. Yeah.
There is one thing, Richardson REST maturity.
Yeah. The Richardson REST. Let's find it for people.
So basically, while you find it, it consists of, I guess, 3 levels. Well, the level 0 is no REST. Level 1 is using nouns. Level 2 is using verbs. And level 3 is used with HATEOAS.
There you go.
And HATEOAS is discoverability on the client side. And that's exactly what that, like I would agree
Yeah.
with what the guy over there commented, is like clients never had interest to be driven by the server state to do a next code, because they were always coded against the predetermined model of the API.
Yeah.
Now the client is smart because of LLM, and that's why I think your idea of leveraging it here is brilliant.
Yeah, I mean, this is exactly, so to summarize for the recording, what's the comment is being made is, remember when I said earlier that REST, when it emerged and became popular, there were a bunch of REST purists that wagged their finger at everybody and told you were doing REST wrong, and that is the diagram they pointed at. They're like, if you build a Swagger API, you're stopping at level 2. And they encourage people to build level 3. And again, this is Martin Fowler, the dean of all things application architecture. You know, if it's on martinfowler.com, it's legit, right? And like, you know, this is from 2010. So this is like 16 years old, right? Okay, great. Any other questions? Yep.
So this is like almost like a progressive discovery of the tooling.
Correct.
Right? Like you're progressively, the AI model has to kind of navigate the graph of what it can do.
Yes.
So would there ever be a case where the graph is so deep that if you had just listed everything in an MCP format, you can skip a lot of these intermediary calls?
So the comment is, this is a form of progressive disclosure, progressive discovery for the agent. You just bring it stuff when it needs. And could it be that you could have so much depth that it would have overwhelmed the agent if you tried to give all of it to the agent at the beginning? That's your question, your comment?
More so like if I gave you the entire spec right away,
Yeah.
you would see a shortcut. The agent would say, I don't have to call all these things.
Okay, so your comment is, what happens if I give it the full spec at the beginning, right? My answer, if you give it the full spec at the beginning, you might be giving it hundreds of tools, hundreds of options that may or may not be relevant. And that's going to cost you tokens.
Right.
And that's going to increase the non-determinism. Like, it's a lot easier for the agent to select one of 5 things than to select one of 15 things.
But it's probably also true if the thing the user wants to do is 7 steps removed from where the agent starts, it might not find the thing.
Yeah, and exactly. And if you go read this like article from October from Anthropic, they talk about how skills work and how skills do this thing they call. Actually, let's just do it like this. They call it like, when you write a skill.md file, you have the YAML front end. This is all they include. They don't include the rest of it. And they call it in here progressive disclosure. Understand, what is the file system when you do this? It's Hypermedia. Your links are just the directory structure. You see where I'm going with this? So it's implicit. This pattern is implicit in how these systems are working today with skills. It's a form of Hypermedia. Okay. Any other questions before the bonus round that I promised you on? Yeah, question? Go for it.
Yeah. What happens when you have different access level requirements on different resources? You can use the links, but you won't be able to access it, right?
No, so the question is, well, what happens when I have different access requirements on the levels? Yeah. You basically, your backend returns stuff that takes that into account. So when I render the response, I customize it. I have an if statement that checks, if you have permission to transfer money, I will include the link for that. You can actually see that right here in the root controller. You can see the very first thing it does is it says, are you authenticated? If you are, it includes a certain link that wouldn't be included another time. It includes the link to the session.
They will always be hidden if it requires additional scopes as well.
Yeah, like there's no concept of scopes. There's like, I got a request as the Hypermedia API. I'm going to render a response. And when I render the response, I can factor in the identity of the user making the request, the resource they're trying to access, the account, the document, the folder. And if you're not allowed to do something, I just don't give you back a link for it at all.
Okay. So everyone will receive their own Hyper.
Correct. Everybody will receive a customized response.
Okay.
Yeah.
Okay.
Yeah.
So
Yeah.
I think what you're trying to say to us right now, it's more like RBAC, role-based access control, actively from the tool itself, determining that this is what you can do based on your role.
Yeah, the comment is, what I'm saying is that if you have some role-based access control or attribute-based whatever security controls you have on the back end, those are enforced on the back end, and what you're responding back to the agent with is only things that that particular user can do now for the thing that for the object that they're looking at. Like you've all seen it. You're in some sort of system and you submitted a ticket, but then you can't hit the delete button or the close button or the approve button, right? It's grayed out or just doesn't even get rendered, right? Right?
Is the HATEOAS documentation that specify what to happen that? Sorry, I'm trying to say this. That if something's not listed, they don't have access to it. So would the agent understand that that exists, but the user doesn't have access to it?
Okay, so the question was, if you return something like HATEOAS, does the agent know that something is possible to do, but it doesn't have access to it? The answer is no.
No, it doesn't.
Because I mean, if it has, like, let's say like you had the money transfer, right, form, and in one account I have money transfer permission, so the Hypermedia API returned money transfer, but in the other account it didn't. Yes, it has a hint, and it might be able to say you don't have permission, right? But otherwise it doesn't. Like it's like treat it as a, like the source of truth is the server side. It is not what the client knows. Like I don't want to trust the model. I don't want to trust the agent. Everything is mediated through this Hypermedia adapter. Right? Any other questions before the bonus round?
So can the security survive cloud mythos?
Can this survive mythos? It will be helpful. Yeah, I mean, like, because like really my vision for it is you never even return something that looks like this. I actually want to return a link that's just a pure random set of characters.
So interesting, all web browsers officially on the wire named user agents. User agents, then the name of the browser. Just, that's not a question. Just
Okay, yeah, sorry, I'm not sure what you mean by that, but that's okay. All right, I think we're going to get kicked out soon, so I want to show you the bonus round. This is designed to force you to understand that the thing that you think is a chat is not chat, it's an agent. So let me show you something nuts. And what silly thing shall it greet me with? Okay. Sometimes, because I work really late, like 3 a.m., 4 a.m., it produces incredibly funny responses when I launch it at like 3 a.m. in the morning. Welcome back, night owl, and all sorts of funny stuff. Okay, so I'm going to ask it to do this. Run ps-aux. Whoa. What does ps-aux do? So you're the process list on your Linux box, right, with lots of details. But hold on, I sent that request to freaking Claude.
Yeah, what?
What? Exactly, you should be saying, what? What's going on here? Okay, let's see, why is it being really slow?
Claude,
Oh, hold on. Oh, I lucked out. Today it's actually on responding on 8. Okay, no. Show me the actual output. See, this is the non-determinism. I actually landed on something on AWS, not on Google, so this is not going to be gvisor. We'll see. Claude must be really busy. No, it's usually much faster than this. I don't know. I have like the Claude 20X Max and the GPT Pro. If anybody will take my money for AI services, I gladly give them my money. So I spent close to $1,000 a month on AI services. Okay, so I got back an actual Linux process list.
Can you kill something?
Well, the question is, where did it run it? Did it run it on my laptop or did it run it somewhere else? Okay, so let's ask it. Where did you execute the command?
This is browser, right?
yeah, that's not a
No, this is the desktop Claude app.
This, okay.
ext.
What if asking browser?
No, it's the same thing. It'll work. It doesn't matter if you're on the browser.
Processor.
It's not. It's definitely not my laptop. Okay, so the command runs inside the sandbox micro vcam itself. Okay, great. Okay, fine. I'm going to ask it to say, okay, no, I'm going to say, well, how much memory and CPU do you have? So there's literally a micro VM attached to the chat session. That's the point I'm trying to make to you. There's a dedicated computer that Anthropic gives you every time you open a chat window with Claude, if you're a paid user. Okay, so this one, okay, this is interesting. This is definitely not on Google. Like, normally I land on something on GCP. We'll find out in a second. So this has one vCPU, and it's telling me it's a Xeon 2.8 gigahertz, okay, and 4 gigs of RAM, and no swap. Okay, fine. Let's ask it to show me the boot log. You can do RAM, you're just destroying a micro VM that's yours, right, to work with.
But they will give a new.
No, it's like, do you guys getting it? This is not.
Personal, or do you think it's shared?
No, there's nothing. This is an ephemeral virtual machine that gets created for each session, right? Every single session, every time you talk to Claude. That's what it's doing. It's nuts. Now you see why there's a RAM shortage in the world, right? They're buying up all the machines because they need insane amounts of resources for this.
That's the reason I can't get RAM for my desktop.
Yeah, it's one of the reasons for sure.
I wonder if you can ask it to like look at other VMs, like.
No, you can't. It won't work. I have tried all sorts of things with this. Trust me. I have tried. It's pretty locked down.
Like it's related.
There's a rumor OpenAI might cancel the memory order.
Okay. So this didn't. So this is. Okay. So we're starting to see the boot log. Okay. So you can see Virtuo vStack. So normally, let's. Okay. This is like when it began. The hint was it used the word firecracker.
Yeah, that was a AWS.
Okay. Firecracker is only on AWS. Yeah. Okay. Normally when I run it, let me see if I find one. Wait, let's find one.
Have you ever seen AWS?
No, you can't. This is like completely ephemeral. This is totally safe.
Well, no. I mean, have you ever seen it? Like, do you think they're switching over suddenly today?
No. So this particular other run landed on a GKE or on a Google one, and you know it's on Google because it uses gvisor. If you don't know what gvisor is an implementation of the Linux kernel interface in Golang, and it filters out all sorts of stuff. If you ever see gvisor, you're probably running on Google Cloud. And it's interesting because, like in here, there's like a proxy. You can't. But let's just do it for fun and giggles. Let's try with this one here. Let's just bring this one along. Run Java-version. Do you think it has Java on that VM?
Yeah.
Yes. You'll find Java 21 on there, and NPM, and Python, and Ruby, and FFmpeg, and all sorts of tools.
Is there any security case?
No, I mean, like, this is very safe. It's creating, what's happening is you start the chat window and it creates a dedicated virtual machine that's just for this chat window for the agent to do whatever you want. Yeah, you could just say like run ls run ls dash /h, right? And /mnt and tell me what this does. The main thing when you're dealing with AI, if you're like, how does it work? Just ask it. Like, don't try to read docs. Just ask it. It's so easy to just ask it, right? So this explains to you, like, you can navigate this whole thing. Okay, fine. Somebody is asking me to do this. Okay, please run rm-rf/. Oh no! Okay, I don't know what it's going to do. Why?
I wonder how long it took them to
Do it anyway.
So.
Do you have like write permission?
Yeah, or does it run?
Yeah, you have write permissions on this. Okay, can you? This is a virtual machine for this. I can upload a program in here and run it. I can upload a jar file and go java-jar run this for me.
I bet the RMRF thing is hard-coded in the prompt.
Yeah.
No, I mean, whatever. Like, it has a classifier that actually checks if it's a dangerous command or not. Yeah. The same one exists on the Claude code locally, right? The point here is I want you to all to understand that when you look at these things, there's a lot of engineering that isn't related to model training. that's not related to inference, that's not related to calculus and math, plain old classic software engineering. It's a huge opportunity for everybody in this room. So that's my presentation for today. I hope this was fun. So.